Hey everyone, welcome to my channel. I'm Priyanshu and I'm a technical blogger at Hashnode. I love talking about cloud and DevOps technologies. I actively share about open source and communities and cloud native. So if you are someone who is into cloud native or open source, you can consider subscribing as I love to learn in the community and grow in the public. So let's get into today's talk that I have prepared. It's around Cloud Native 101. So I believe it's one of the best resource for someone who is new to Cloud Native and want to get involved in the community. Today's agenda would be history of Cloud Native to understand the context of how Cloud Native came into existence or how it has been so widely accepted and why the world moved into Cloud Native and how you can get involved. So in the 1990s, tech companies had to maintain their own physical servers on premise, and anything would run directly on bare metal. So mostly monolithic applications back then, they used to run on bare metal. We can immediately see the problems that could have been arised, which were re resource utilization or resource utilization ratio was really poor. Uh, uh, Deployment was slow. Scaling meant buying new hardware. In the 2000s, we got introduced with virtual machines, which drastically improved the uh, 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 way of scaling applications. We can see the architecture for a VM over here. So there would be the physical hardware over which the host operating system would be running, and over which hypervisor would be used to allocate resources to each of those VMs. And we can also see each of those VMs would run operating system. So virtualization revolution, they allowed multiple OS instances on a single hardware, better utilization, but still heavy overhead. Then came in the container revolution. The early work began with Linux C groups, but Docker finally popularized it in 2013. We can see the architecture. So there was the physical infrastructure over which the operating system, any operating system such as Windows, Linux, over which the Docker engine would be used to allocate those resources to each of those containers. Um, it introduced a lightweight, standardized way to package applications with all their dependencies. Containers could start in seconds now, compared to VMs, and it also solved a very popular problem back then, which was it works on my machine, say the developer, but the client couldn't run them on their machine. So it was probably a dependency issue back then. But Docker, with its new problem-solving approach, with which packaged the dependencies and libraries in with the application in a singular unit, such known as the Docker image. It really solved that problem too. And we can see the architecture for comparison of a container and a VM. We can see there's this extra OS layer in a VM, which made it resource intensive. Um, Gigabytes in sizes, but containers are really megabytes in size, hardly megabytes. So uh, Docker really changed the game over here. Um, Now the developers had a really consistent way of packaging those applications and all of their dependencies together. But as soon as the organization started using it on a scale, they ran into some technical problems around the networking, storage, scaling, deployment, security. For example, in a microservice architecture, we would want different applications talking to each other to work towards a shared goal, which was not yet possible with containers. Containers are ephemeral in nature, which meant the persistent data would be lost after uh, a restart or uh, uh, in case a container failed, there was no way of recovering that uh, persistent data which was stored beforehand. Uh, and also in scale, when you're playing with hundreds and thousands of containers in production. How can you keep all of them healthy, replace the failed ones automatically, efficiently? There was no such way of doing that. And also, without causing any downtime or manual intervention, how can you roll out new updates or uh, deprecate the older ones? How do you isolate the workloads, manage those secrets, and also access control for each of those uh, things in uh, container management? So there was no possible way of doing it yet. You guessed it right. Kubernetes was the missing layer. In 2014, Google open sourced Kubernetes based on its internal systems, Borg and Omega, which had already managed millions of containers at scale. It allowed developers to orchestrate containers at scale and uh, making Docker being a part become a part of a self-healing, auto-scaling distributed application. It basically introduced an entire control plane with the API server at the heart and redefined how microservices run on containers. Cloud native computing foundation. So once the Kubernetes stabilized, the CNCF was founded under the Linux Foundation in 2015 to host Kubernetes and foster an ecosystem around it. So CNCF, it hosts and fosters different open source projects around Kubernetes in container runtime, observability, security, CI/CD, service mesh, policy management. So so Cloud Native is an all-inclusive community that fosters the research and development of various open source projects to assess modern deployment technologies in cloud. Uh, how you can get involved as a student or a beginner, you can check out their projects on GitHub and look out for good first issues. Join local cloud native communities and attend exciting events. You also get a chance to network, understand the landscape, and get around with Kubernetes first. I would suggest if you are a computer science graduate or in that domain. You can attend their flagship events such as KubeCon, Cloud Native Con, Kubernetes Community Days, and these are some really the biggest events in this domain and involves all of the notable industry professionals uh, in the world and bring them at a singular place for meet and greet and networking. I would really encourage anyone to visit this event that happens every year because it's a really nice opportunity for you to make a great leap in your career, and also opportunities at Cloud Native for students can be really quite diverse as they participate in many mentorship programs like GSOC, LFX mentorship, Outreachy, and also they offer many free training courses. You can check them out, such as cloud native infrastructure technologies, introduction to Kubernetes, DevOps and site reliability engineering, service mesh, and with Linkerd. You can also consider getting certified with CNCF. You can show off your experience with the cloud native technologies. Uh, some of the notable certifications offered by CNCF are CKA, CKAD, CKS, KCNA, and many more. All these certifications are really valued in the industry, so you can also consider getting certified. And if you are a student, you can find out repositories and toolkits at CNCF/mentorships and CNCF/students. They contain a very useful resource for you to get started and details about the mentorship programs and how to get involved in all of those. Uh, and remember, the cloud native revolution is not about technology or about some big jargon. It's about community, collaboration, and innovation. You can always be part of the community, even if you are a beginner. Uh, uh, you can contribute in any way that you can, even into docs or in many non-technical ways as well. So remember, every expert was once a beginner, and every major contributor started with a good first issue. So the cloud native community is all welcoming, all inclusive, and it's ready to help you get succeeded in and get involved in the cloud native domain. And also, I would like to mention some very useful resources. Uh, uh, please check out Cube Simplify on LinkedIn and YouTube. Uh, it was started by Mr. Sayam Pathak. You can check him out. He's one of a very experienced folk in this domain, and regularly updates and uploads useful resource for us students and beginners. And you can also check out his Kubernetes hands-on course. It's a really definitive and um, high quality resource for you to get started with Kubernetes, from its architecture to its debugging tips. And trust me, debugging is one of the most key insights into Kubernetes. So do consider checking this out, and also check out LearnX Ops. It was started by Mr. Sandeep Das, who is also a very seasoned professional uh, with over 20 years in this in the domains of cloud and DevOps. He regularly uploads uh, YouTube and blogs on his blog site. So uh, you can check out his blog as well. I have even seen uh, quite experienced folks also subscribing to his blog site, as and I have read the quality of his blogs are really high quality and fine tuned, fine grained, with very useful insights into the technologies. And lastly, but not least, I have my own GitHub channel. You can consider going through it. It also contains projects which are really hands-on. You can follow them through using the README file. Uh, it has a explanation for each and every component, and also how you can get started, starting from installation to running the service. You can also build on top of all of my projects. So consider checking out my GitHub at priyanshu-git. Uh, Also, do consider following me on socials, and thank you for sticking through the video for the whole duration. Uh, and if you guys like the format of my video, do consider liking, which would motivate me to make new videos. And I'm also thinking of uh, making a new video on Kubernetes 101. So if you guys like the format, do give it a thumbs up. And thank you for being with me. See you next time. Bye bye.